This has been a particularly exciting week for Billy and Kathy Rogers. For one thing, their father, Air Force Captain Michael Rogers, is a member of that select group of American astronauts participating in the Apollo Man-to-the-Moon program. Yesterday, he returned home after completing his debriefings following an experimental spaceflight mission. And today, just as the excitement was beginning to die down, Billy and Kathy's McNally World Portrait Globe arrived. Now it is after dinner, and Billy and Kathy are eager to hear more about their father's spaceflight, particularly with their new globe in their hands so they can see exactly those areas which the space capsule passed over while orbiting the Earth. Billy is the first to speak.
Dad, Kathy and I would like to take our globe to school so we can tell the kids all about the flight. Show us just where you went.
Does the Earth really look like a big ball from up there?
Does the United States look as green as it does on the globe? Can you see the mountains?
I still don't understand why you didn't land back where you started.
Wow, let's take one question at a time. As a matter of fact, why don't we use your globe to pretend that we're astronauts? We'll just launch ourselves into space and answer all your questions, and perhaps learn a little more about our planet Earth as we circle around it.
Okay, great.
Are your imaginations all set to go into orbit?
Yep.
Billy, you give us the countdown, and we'll pretend we're blasting off from Florida.
5, 4, 3, 2, 1, blast off!
Hang on. We're cutting through the cloud cover now, and pretty soon our capsule will be in orbit position. And now we're in orbit. During blastoff and entering orbit, we astronauts are pretty busy operating our space capsule controls. But when we get the time to look around, the first thing we see is the Atlantic Ocean. It looks like a deep, brilliant blue, just like the blue shown in the Atlantic Ocean on your globe.
Does the Earth look round?
Well, if you put your finger on one of the raised mountains on your globe, you'd be about as far away from the flat surface of Earth as our space capsule is. Remember, the Earth is 7,918 miles in diameter. We're only 160 miles above it. We can see the horizon curving away in the distance much more clearly than we can while we're standing on the ground. But in order to see the Earth as a ball, we'd have to be several thousand miles away. As we begin our orbit, turn your globe slowly towards the African continent. Keep your eye in a line from the tip of Florida towards Morocco on Africa's west coast.
What are these mountains out in the water of the Atlantic Ocean? Can we see them as we pass over in our capsule?
Well, those mountains are underwater, Kathy. We can't actually see them from our spacecraft. But did you know that the deepest valleys and the highest mountains on Earth are under our oceans? One of the longest mountain chains on Earth runs right down the Atlantic Ocean. Because these mountains are underwater, they are painted on your globe and not shown as bumpy ridges like the mountains on land.
Yeah, that's called raised relief on a map or globe.
I know that.
As our spacecraft begins to pass over the African continent, we notice a distinct difference in the color of the Earth. As you turn your globe slowly towards Kenya on Africa's east coast, along the path our space capsule is taking, you first see different shades of brown covering a large portion of the continent's northern section. This tells us we're passing over a vast desert. Your globe tells you this is the Sahara Desert. Look at the raised portions of the desert on your globe. You can see that there are mountains in the desert, some of them as high as 10,000 feet. Billy, do you know why this section of Africa is a desert with little or no vegetation?
Sure, there isn't any water.
Well, there is some water, Billy, but it amounts to less than 10 inches of rainfall each year. And except for the Nile River running through the United Arab Republic, there is no source of water for man to irrigate the land. As a point of contrast, remember that the rich green tropical rainforest areas of the world have between 40 and 80 inches of rainfall every year. Now, as our space capsule continues its course towards Kenya, we see the desert sand giving way to green grasslands. From our spacecraft, the Earth looks pretty flat, but our globe tells us there are rolling hills and even mountains. From our capsule, we can look off to the north and see the Red Sea, where it meets the Gulf of Aden. And then the Earth curves away into the distance, into the Arabian Peninsula. Before we know it, we've completely passed over Africa and start crossing the Indian Ocean. The next recognizable land we see will be the continent of Australia. Turn the globe slowly and continue our orbit along southern Australia. Our orbital path will continue on a line from the southwest point of Australia to Adelaide and then we'll pass over the southeastern tip of the continent before continuing over the Pacific Ocean. If we keep on going around the Earth, our later orbits will take us over most of the Australian continent.
Why won't we go over the same spot?
Well, for the same reason that we won't land in the place we took off from. You see, the Earth is rotating like this globe as I spin it counterclockwise. Since the position of the orbital circle of our spacecraft stays the same once we're in space, and because the Earth is rotating while we are orbiting around it, we keep covering new ground. For example, take a piece of wire and shape it into a circle slightly larger than the globe. Hold it around the globe on a line from the tip of Florida to Albany, Australia. This represents our current orbital path. Now turn the globe slightly counterclockwise, which represents the Earth's natural rotation. You'll see that when we complete our first orbit and pass over the United States again, we'll go over Alabama and Georgia rather than Florida where we started.
I get it.
If we keep going for 16 orbits, however, the rotation of the Earth would bring us back to the area of Florida because 16 orbits would take us about 24 hours, and the Earth would have made one complete revolution, gone through one night and one day to bring Florida right back under us.
Will we pass through a night during our first orbit?
Yes, Billy, we will. In fact, it's nighttime in Australia. You see, Billy, Earth is part of a solar system which is dominated by the sun. You know, if you place the globe next to a lamp and pretend the lamp is the sun, you can easily see that when the United States is facing the lamp, Australia is on the other side of Earth, away from the lamp, or in nighttime. Because the Earth rotates once every 24 hours, we have one night and one day in every 24-hour period. Does this help you understand why it's 12 noon in Chicago when it's already 6 p.m. in London and close to midnight in Australia?
Gee, I'd never thought of that.
What are we going to see next, Daddy?
Let's take another look out our spacecraft window and see what's below us now. Okay, let's keep this spaceship on course. As we pass over Australia and continue across the Pacific Ocean, our orbit takes us on a line heading towards northern Mexico. As we cross the Pacific, we pass over numerous islands before we see the Mexican west coast. We cross Mexico just north of Mexico City, and we can clearly see a mountainous terrain. We can see the snow on the mountain peaks and the shadows in the valleys. If you touch this area on your globe, you can see that the land is raised up very sharply.
Dad, look how the mountains run up all the way from the southern tip of South America clear to Alaska.
That's right, Billy. As a matter of fact, if you continue to follow them through Alaska, it's almost the same mountain system running completely around the rim of the Pacific Ocean. Follow the chain to the Bering Sea off Alaska, then down through the eastern Soviet Union, Japan, and Indonesia. It's almost one continuous circle.
That's right.
There is another fascinating mountain system which begins in Spain. Turn the globe back to Spain and follow the mountains through Spain, across the Mediterranean to Turkey, and through all the massive mountains in Afghanistan and Tibet. You can see that China and Nepal have the most rugged mountains in the world. And do you know what they're called?
Those are the Himalayan mountains.
That's right, Kathy. It's interesting that when the United States Army was flying cargo planes during World War II, they flew supplies from India into China. They called it flying the hump because, as you can see, the Himalayas do make a prominent hump in the Earth.
Okay, let's now go back to where we left off with our spaceship. We were passing over the mountains in Mexico.
Yes. Now let your eye continue on a line across Mexico just north of Monterey, eastward over Houston, Texas, southern Mississippi, Georgia, and over the Atlantic Ocean at the approximate location of Charleston, South Carolina. Now we've completed one orbit.
Does this make us full-fledged astronauts?
Well, I guess maybe it would.
Say, Dad, you didn't say anything about the cities we went over. Are we too high in the space capsule to see them?
Oh, no. As a matter of fact, Billy, the cities show up very plainly, and you can even distinguish individual buildings, although perhaps not well enough to identify them.
And what are the other things you can see?
The highways, roads, and particularly the big wide expressways in the United States show up very clearly from our space capsule. Dams, reservoirs, and cultivated areas can be spotted too if you look hard enough for them, but you do have to look. There aren't too many ways in which man has dramatically changed the face of the earth so that you can see his influence clearly from as high up as we are.
Dad, on our second orbit, we would pass south of the Sahara Desert in Africa because of the Earth's rotation.
That's right, Billy. Because of the Earth's rotation, our orbit would take us south of the Sahara Desert, over Mali, Nigeria, the Congo, and the northern tip of the Malagasy Republic. As you can see, these areas are colored light and dark green on your globe. Kathy, do you know what these colors indicate?
Well, the light green places are grasslands, and the dark green is probably jungle.
That's right. You can see that in the United States and Canada, there are also light and dark green areas. But we don't have any jungles or tropical rainforests, do we?
Oh, but those are lighter shades of green from those in Africa. You know, over on the other side of the globe, where it says Rand McNally World Portrait Globe, this box shows that there are green shadings for needle-leaf trees and broadleaf trees, and that the darker green is for tropical rainforest.
That's right, and I guess you've gotten ahead of me. I'm glad to see that you've learned that one of the first things you do with a map or globe is look at the explanation, or legend as it's called, which tells you how to use the globe.
Hey, Dad, you know, if we could just swing our space capsule on an orbit a little farther south in Africa, we would pass over the north part of Australia.
That's right, Billy. It might seem strange that if our orbit passes over northern Africa, we soon cross over southern Australia, while if we cross over southern Africa first, we soon pass over northern Australia. But remember, kids, the Earth is rotating on a tilted axis of 23.5 degrees. Using the wire circle we made earlier, you can see that the straight line of our orbit would make this true because of the axis and Earth's rotation.
Well, Dad, in that case, we could drop down and land where the globe shows the Great Barrier Reef, just off northeastern Australia. We saw a movie about Australia in school, and I remember that they do this. What do you call it, where you ride a board through the waves?
Surfing?
That's right, surfboarding.
Well, Billy, our second orbit wouldn't take us that far north, but we'll get there on one of our successive orbits. The surf off Australia's coast is some of the highest and most rugged in the world. Excellent for surfboarding. Billy, probably that movie also told you about the great dividing range of Australia shown on the globe along the eastern edge of the continent.
Doesn't that have something to do with how much rain there is?
That's right. East of the Great Dividing Range, there is generally a heavier rainfall. Because of this, there's a good deal of agriculture along Australia's east coast. On the part of the continent around Adelaide, the climate becomes more moderate, which makes the region particularly suitable for crop farming and gardening. Australia is probably best known for its vast cattle and sheep ranches. These are located in the continent's interior. Your globe shows you this region is primarily treeless with scrub vegetation, except for the very center, which is desert, unsuitable for cultivating or livestock. Australia, as you can see, has a great many contrasts in geography that we can detect from our space capsule, or our globe.
Can we see any kangaroos?
Well, we're a little high to spot kangaroos on the ground, but they are there, and primarily found in southwestern Australia.
Dad, look! Here's Western Samoa out in the Pacific.
Yes, as we continue our orbits, our space capsule will go from Australia across the Samoan Islands, and again we'll pass over Mexico. Only this time, we'll be north of where we traveled in our first orbit. Then our orbit will take us across the southern United States.
If we keep on orbiting, we will eventually pass over Europe.
No, we won't, Kathy, because of the way our space capsule is launched to bring us over our planned landing area in the Pacific Ocean. But if you want to plan your own space journeys over other parts of the Earth, you can just stretch a piece of string around the globe, and you'll be pretty close to a one-orbit path.
Gee, we could start any place. We wouldn't have to start in Florida, and we can just pretend that we are astronauts looking down and seeing the things that we see on the globe as we go over Europe or the Soviet Union.
Yes, and you could use our atlas and the encyclopedia to look up some of those places and find out what they're like and what the people are like.
Kathy, let's make up our astronaut game. You make up an orbit with questions you'll ask me, and I'll make up an orbit and questions for you.
Okay, let's start.